In this video, we have a function g, and it's defined as the set of ordered pairs -7, 7, -6, 5, -4, 0, and 0, -9. And what we want to do is we want to use that set of ordered pairs to figure out the g of -6 and the g inverse of 0. So let's talk about what these ordered pairs represent first of all. So if each of these, of course, are going to be x and y values, so coordinate pairs, and each x value is paired up with its y value. So you have input, the x values, and output would be the y values. And so the original g function is going to take, x values and it's going to turn them into y values. And so that's how you can think of normal functions. You put the input, which is your x, and you change it to a y. If we're talking about g inverse though, the inverse function, an inverse function does the exact opposite. It takes the y values and it maps them back to x values. So it kind of undoes what the original function did. And so when we're looking at these two problems, first of all, looking at the g of -6, what you want to do is you want to say, okay, -6 is going to be the input value, so that's going to be an x value. And it's going to take that x value and it's going to match it up with whatever its y value is. So looking up at the original function, we can see we have the ordered pair -6, 5, where -6 is the x value. So the y value that corresponds with that is 5. And so that's our value for the g of -6. So that's going to be our first answer. So that's not too bad. That's the kind of thing we've done before, but now we're relating this to the inverse function, because the second problem is we want to know the g inverse, and that's what that little -1 means. It doesn't mean to the -1 power. When it's in function notation, it means the inverse function. We want to know the g inverse of 0. So looking back over here at what I wrote, first of all, the g inverse is going to take y values and it's going to send them back to the original x value. And so this 0 right here is a y value. So the input for an inverse is going to be like the output of the original function. And that's why the domain of the original is the range of the inverse, and the range of the original is the domain of the inverse, because you're just switching the x and y values. So to figure out this answer, we look through here and we say, okay, this point right here, or this ordered pair, has a y value of 0, and we already know g inverse of 0, we're looking for a y value, and so what we want to do is we want to write the x value that's tied with or corresponds with that y value of 0, and the answer is -4, because that's the x value of this ordered pair right here. And so that's going to be your answer for the g inverse of 0. So just keep in mind, if you're given a function, let's say f or g, and you want to know the f of something or the g of something, you're always looking for an x value that matches that, and you want to give your answer as the y value that's corresponding with that x value. But the inverse is the exact opposite. You want to go and find the y value that matches the function input value, and then you want to see what x value is tied to that.